All right, we're going to move forward. We got a customer service update. A lot of you have spoken to them over the phone or on a Teams chat or via TeamViewer. We got the one, the only, Mr. Adam Middlecoop.
Hello, hello. I've been told I need to go quickly because the more I talk, the less time there is for Jeff. So we'll decide if that's a good thing or not. So yeah, Adam Middlecoop, customer service. Go over a couple little topics today. A reminder on what we need to be effective in helping all of you. Some of the virtual offerings that we've been forced into by the world we live in now. Go briefly over the legacy AUI app. I'm going to cover off some power supply changes, which is a hot topic, I'm sure. And Lisa pleaded with me to give a few details about repair shipments. So starting off, the things that we need. Need transmitter model, transmitter serial, account details, so that'll be call sign, who you are, what the company is, and fault details. This is an instance where more is more. On the left is kind of what we'd love to get, and on the right seems to be what we end up with most of the time. So why does the model and serial number matter? A lot of our transmitters have pretty long production cycles, which leads to variations in the builds. That'll be through part revisions or straight up part changes. And ultimately it comes down to being able to determine if what you need is a drop-in part or if we're going to have to provide a field modification kit to support it. Now, part numbers matter, high accuracy. I had to dig a bit to find a part number that had an example of everything I want to talk about here. And I'll give Jeff until the end of my presentation to figure out what this board is. So if you see NAPC 110B/03A, that's a whole lot of gibberish. What does it even mean? The letter sequence at the start, that's the part type. In this case, I'll give you a hint, it's a control board. Then the next number will be the part model. So this is an NAPC 110. The letter that follows, that's a part revision. And then the slash, and then the number, that's a variant. And then the letter after that is a revision of the variant. So that's all fine and well. Now, what do we do with that? So rules wise, the part type and the model have to match. You're not going to replace a control board with a power supply. You're not going to have any luck there. So we need to match the part type and the model. And for revisions, the letters increment upwards, and you can replace a higher value can replace a lower number, but you shouldn't replace a lower with a higher. So a B can replace an A, but an A probably shouldn't replace a B. For the variants, these absolutely have to match. So if you have a /03, it has to be a /03. There's really no exceptions to that one. The revisions, they follow the same kind of rule. So a B can replace an A, D can replace an A, anything higher can replace lower, but lower shouldn't replace higher. And the part revision also still has to follow its rules. And if things don't match, so for the part type and model, sometimes we'll change the assembly out completely. There'll always be a field modification kit for that. It'll have the parts you need, the instructions, any caveats, any concerns, it'll all be covered in there. So that'll only happen with a field modification kit. For part revisions, you could end up with compatibility or performance issues. Some lower revision parts were changed for compatibility issues, or they just work better. For variants, you'll notice mechanical or electrical differences, which is why they're so key. So you will have severe fitment or function issues if you mismatch that /0 number value. And for the variant revisions, same kind of idea, potential performance or compatibility issues. Ultimately though, if you have a question, just ask, that's what we do. Another note on that, interchangeable assemblies might contain incompatible sub-assemblies. So a power module that is just a simple letter revision change might be made up of a bunch of stuff that won't play nicely. NV is kind of notable for that. There's some variants of the PAs. And so while the whole box might be swappable, the guts may not be. That's why it's always best to confirm exactly the part that you need. So look at the broken one, tell us the part number, and we'll get you what you need for that. Fault details matter. So the red light is on. It doesn't work. That's not the most helpful in the world. So if you can tell us exactly what happens and when, so I press the on button, it starts to run up, and then this shuts off. That's a lot more useful than it's not working. I had one day where 3 people that I talked to had gone up a mountain to a site, saw a red light, drove down the mountain, went back home and called in. I can do absolutely nothing for you in that case. So get absolutely as much as you can. I can ignore the things I don't need, but I can't really invent what I don't have. So more is always more there. And check the alarms and words. Anything after the V series will tell you in words what it's upset about, and that's infinitely more useful than an LED. And this last little note here, we know the alarms that exist. A game people like to play is this a real alarm or not? So just read the actual alarm and we'll be able to help you out. Sometimes we'll make fun of the wrong made up alarms. So moving on to some of the virtual offerings we've been sort of forced into given the current climate in the world. We've moved into doing some virtual FATs. We've got a bunch of web-enabled cameras that the test room guys will set up at appropriate angles. And then we can log in through Teams or Zoom or Skype to provide visual access to that, which is useful. Less so now, I suppose, where travel is a little more possible, but we ran a bunch of them early in the before time, if you will, and had some pretty good success there. And for support, as always, TeamViewer is an option. The AUI remains an option, either through a direct IP access, or we've done several instances where we'll TeamViewer into a laptop that has VPN access to a computer that has access to the transmitter. However long the daisy chain has to be, we can get in there and it works out pretty good for us. Which leads us nicely to the legacy AUI Access app. So it's a program that is basically a standalone web browser that's running the last released version of the Flash player. So it'll allow access to the legacy app, or to the legacy AUI, where a lot of browsers have now shut it down entirely. So there's a version for Windows and Mac OS. They're fully supported. Some folks have had luck running it on a Linux box with Wine, but that's not a customer service supported effort. So try it at your peril. There is a minimum software requirement for the transmitter. There's a list of what that version is for what transmitter family in the installation document. It was early 2016, I believe, February, something like that, when Adobe made a change to Flash Player that broke our login script. It decided it just didn't want to run it because it didn't like it. So what'll end up happening is you'll put your username in, you put your password in, you click submit, and absolutely nothing happens, and you end up sitting at that timed out for no login screen. That's because you're at a version that's before we fixed the login. And since this legacy app uses the final released version of Flash, old computers that were running old Flash probably played nice. This requires at least the version listed there. I think we're clear of most of them, but there's some VS out there that were from very early software versions, your 1.0s and your early 2. And it's a bit of a trick to get into anything compatible with this. If you're in that situation, just contact us and we'll get you through it. So the hot ticket item is our power supply changes. So things that have changed, the UG69 series power supplies, those are used in VS and NV. And then there's some changes to the UG92 power supplies that are used in the NVLT and GV transmitters. So for UG69, the company that made them is no more. The UG69 is dead. Long live the UG69. So we have an adapter assembly that uses the UG132 series power supply. So it's part number is NAS70. That comes as a kit, so it's the housing and the power supply all as one. For each position of UG69 power supply you need to replace, you'll need one of these assemblies. After you install it, the replaceable unit is just the UG132 power supply. There we go. So there's a field modification document, FM20003, that covers off what you'll need to do to install them. And it has some usage restrictions. Hard to see on the screen, but this table is in the field modification document. So there's some physical restrictions across the entire size range. It's ultimately down to cooling modifications on the door. They just physically won't work, so you can put them in, but you can't close the door because they'll bang into it. So in that case, you'll have to shuffle things around to get to where they fit. For the 16 module transmitters, that's your 30 kilowatts and your 40s. The same kind of usage restrictions as with the J revision UG69s apply. So your fan position where you've got 3 and the IPA position where you've got 3. These won't work in there because they'll just try to do all the work. They don't current share. So they'll drive themselves in the ground trying to do everything. So using an NAS70 and a VS, that is not a supported thing. What we're doing with VS is we're rolling out new power supply distribution boards to directly interface with the UG132 power supply. There's a field modification for that that's kind of in the final stages. We're dotting T's, crossing I's, all that. But it will require a new power supply distribution board so we can interface with that power supply, different connector, different communication method, and there'll be an associated software update that'll have to go with that. It's not all doom and gloom though. We do finally now have in place a UG69 repair program. We've partnered with US Technologies out of New Jersey. So this will be for any UG69 revision from the original all the way through to the J's, as well as the UG105, which is the power supply core that's used in the V series UG39 power supply replacement. So if you have a UG69 or UG105 power supply, it is now repairable. This company, they're saying 495 US per unit to repair. They're anticipating 30-day turnaround on batches, and they're asking that we limit to 10 units per batch to start. And they're offering 90-day warranty on the repair. Arrangements for that are done through us, so just email support@nautel.com and we'll get you lined up with that. So that's UG69, VS, NV, what our situation is there. The UG92 power supplies used in NV Lite and GV, they're basically just being superseded with the UG132 model. So for a power module, that is a direct replacement, 1-for-1, nothing to worry about. Old one out, new one in, not a problem. For the 12 and 16 module transmitters, so your 30N, your 30, and your 40 kilowatt, basically one UG92 has to be replaced with 2 UG132s if it's a low voltage power supply position. Thankfully, these all have a lot of power module positions, so you can swap if you lose an LVPS low voltage supply, you can swap it into a power module position and put the UG92 down there. The 12 and 16 module cabinets all have 4 positions for low voltage power supply positions, so you can just take off the little dummy plate, put the new one in, and there is a menu option you'll have to go through to tell it that it has 3 or 4 low voltage power supplies in it. It'll still work if you don't do that. You just won't have any alarm reporting for the one that you've added. It basically just masks the alarms for the positions that aren't in use. So that's all clear as mud. Repair shipments, this is Lisa begged me to put this in. So any repairs, we need to have an RMA in place before parts are shipped. So you can just contact support@nautel.com to get the things rolling for that. Call one of us or email directly. We get a surprising amount of mystery boxes on the loading docks. And while it's always a fun game to try to figure out who sent it, it's more ideal if we arrange it before it shows up. And items, we want to make sure they're packed carefully. Shipping damage can, in a lot of cases, exceed the price of a repair, and we've actually had units that are completely demolished and just destroyed from shipping. I don't know if they're here. If you are, I'm sorry, but there was a VS 2.5 that came in one time where the power supply bracket wasn't in place. So the 3 UG69 power supplies in there shook around the entire time it was in transit, mangled the fab, mangled the power supply interface board, mangled the power supplies. Then on top of that, the output connector got jammed inside really hard. So just make sure things are buttoned up. It's $12 worth of packing material is a lot cheaper than having to do 3 power supplies, an interface board, and an entirely new chassis. So, and she sent me over a couple pictures of some of the, I guess, horrors that have come in. So we'll have a look at those, and then that'll be it for me for now. So we see these look like, on the left, that looks like it'll be an NV or an NVLT GV power module. The little tabs off the end, they get bent in a bunch. On the right, it's another module that got a little bit mangled. This isn't the end of the world. They can usually bend that stuff straight. It's a little ugly afterwards, but they can fix it. Looks like we got AMFET module with the front panel a little bit dented there. Now this stuff's tricky because we don't have any of these bits left over, like all the fab and any of those pieces. They don't really exist on a shelf anymore. So we can't bend that kind of stuff straight. You're into big dollars to spin up new hardware. Then this looks like a VS where the output connector was removed, and then what was left has been jammed in working hard against that. And so that'll go into a directional coupler and power probe, which may be damaged. So that one would have been a little bit spendy to fix. Got some more modules, looks like they're showing up. Bent tabs, bent handles. Yeah, those little corners, where the screws mount into the frame, those get bent over all the time. And these are the last couple. I can't quite make out what the left is. I think that's another AMFET module, but you know, big damage there. If they can't bend that straight, that would be a lot of time and effort to make up new fab. And bubble wrap is good, and foam is good for packing, but you got to make sure nothing has a chance to wiggle around, or it'll just get munched up like that. I guess to conclude my time here, customer service, we're there for you as we've always been. We're adapting to the new challenges that have been presented to us by the world in which we live these days. But ultimately, our goal is just to ensure worry-free transmission. So I'll be at the booth wearing this, and if you've got any questions, feel free to track me down. But that's it for me for now, and I'll pass it on to whoever it is that's next.
Thanks, Adam. By the way, an NAPC 110 is the control board for an NA 100 kilowatt AM frequency agile broadcast transmitter, just so you know. I will confess I cheated. I looked it up. I didn't need all that time. One of the other things, Adam mentioned this in when he sent me this PowerPoint, he said, we get a lot of stuff back that's packed in hopes and dreams. He's not lying. Hey, does anybody remember in 2019, who was here in 2019? Few hands. Do you remember a certain white-haired gentleman standing up here and going, by next NAB, we'll be flash free? Please join me in welcoming Mr. Matt Hurden.
And here we are, the next NAB, and here it is. Okay, now I got to figure out how these buttons work. So, okay, thank you. So the new AUI is up and running on our VS. It's on a GV, and it's running on, I think some parts of it are running on the VX as well. So the progress has been really awesome. And so for those that don't know, it's an HTML AUI for all Nautel transmitters that have run the old Flash one and anything that we do in the future. It runs on any modern browser. So HTML5 is obviously something that's only supported by modern technology. There's a new Linux operating system that goes across all of those. And therein lies the rub. And that's why it's taken quite a long time, because we're basically taking old hardware from 2009, 10, et cetera, and putting new versions of Linux on it, new middleware, new AUI. And that's where the real work has been. That's where the really heavy lifting has gone on. And so our team has done a phenomenal job of solving a myriad of technical challenges for squeezing this technology onto old transmitters. It also has a lower bandwidth requirement. So the typical Flash AUI is around about 9 megabytes of load when it loads up, and it loads essentially a Flash app into your browser. And the new one is a bit, I think, around about 1 megabyte. So it's maybe a tenth in size. And also the data transfer, we've sort of lowered the data transmission. That may change as we open up more or less, depending on what you want. And what we've got now is something that's robust, it's secure, it's fast, it's flexible. And because we're on a new code base, which is common to all of our transmitters, they use the same actual AUI code on all of the transmitters, that it's flexible because we can sort of work on it and produce new builds and add new features as required. So the development status right now is essentially it's feature complete. We've built all the widgets and things that go on the screen that you saw in that first image. You can come by the booth and have a look at it and play with it. It's got a live one there. The one that I was showing you on my phone, that was the login screen for the VS300 that's stuck to my wall in my office. And that runs day and night and has been running for about a year. And so it's feature complete. The focus right now for the team is on testing quality And so we're going through a lot of rigorous stuff. And one of the things that we found, though, was that the VSs, the really old ones, they ran into some installation issues, which was related to the new Linux system and the way that we're installing. So we're having to do some fine tuning there. And that's working pretty well. And but again, it's just more work, hence the delays. The VS series is in beta right now. I'm waiting for QA to sort of give their blessing to the beta 2.1. That will roll out. A lot of people I've been talking to are waiting for it, and that will be good. But shortly thereafter, and I'm hoping sooner rather than later, we'll have the beta 3, which will be the feature complete sort of gold standard with everything in it, including HD support and so forth. And that will be we hope it to be our final beta, and then the GA, the general availability, will happen after that. The GV series is in productization. So we have all the code, the Linux operating system, the middleware, and the UI stuff. And then we put that onto the GV, onto the VX, the MV Lite. NX was missing from my list. Sorry about that. It belongs there. And then we do the plumbing. We replumb, and that's the productization part of it, so that we adapt the AUI to that particular platform, that series. And so the beta for the GV will be fairly soon. And then it'll be the VX, that's in productization as well. And they're working in lockstep with the firmware team. So obviously there's work going on there. And then NX, MV Lite, and MV are the ones that follow on, and we don't have specific dates around those yet, but it should gather momentum as we go forward and accelerate the rollout. It's important to note what's not in the new AUI. And one of the challenges that we've found is that taking the older hardware and bringing it forward into a new Linux operating system. In the case of the VS, the audio driver is proven to simply not exist. And so we tried extremely hard, like a lot of cycles went into trying to to write an audio driver for the Linux system. And that was so far not been successful. We may revisit that soon. So there will not be an audio player in the VS, at least at this point, unless something changes. We may come up with a different solution, but we're working hard at it. So it's not being ignored. Remote I/O settings are just simply delayed. You can do that from the front panel on the transmitter. So we didn't feel that it was important to include it right off the bat. So there are some things that are just deferred. The mobile optimization. So if you come by the booth and I show you the AUI on my phone, you'll see that in mobile mode, it's not quite perfect. So that optimization will happen later in the year. It works, and you can switch to desktop mode, and it looks perfect, and it's very cute and very tiny. You have to kind of use your pinky finger to operate the buttons, but you can zoom in and zoom out. So it's pretty cool having it on your phone. So, you know, as a kind of a summary, that we wanted to make sure that the AUI was familiar. So it felt like the old one, but you can tell it's really a new one in the sense that it's optimized, it's improved, it's gone through some evolution. And so that's really key. And that leads it into being much easier to learn. So you should be able to pick this up really fast. You'll just sort of play around with it, get to know the icons, and you're off to the races. Access from any device, tablet, desktop, phone, we want that. And we wanted to, one of the things we avoided was creating another app that gets installed on your phone. So Flash was a true app. HTML5 is something that runs in the browser. So the app that's running this is really your browser. And so browsers are everywhere. So we chose to go that route rather than to find yet another Flash-like technology. And we avoided that explicitly. It's touchscreen friendly. I can show that on my phone, and the upgrade to it will be free. When you get the slides, you can get this, but on the support site, there's AUI pages that have links to the new AUI, also to the beta if you want to sign up for that. There's documentation being developed, videos, migration guide. I'll probably do a side by side, so you see the old Flash AUI, and here's the new one, and kind of help you to sort of get to know the new AUI. And if you've got questions, comments, feedback, etc., that's my email. Okay, so what I'd like to do now is I'd like to invite Etienne Guimont, who is the lead on the VX series design team on the hardware. And between him and Justin, who's already at the booth, they, I think, are absolutely instrumental in making sure that we have a VX today. And it's pretty exciting. So we're going to bring this up. So, yeah. Yes. Okay.
Very light.
24.5 pounds, I think, on the 2 kilowatt. 24.5 pounds for a 2 kilowatt transmitter. Okay. This is the 600, which has a single pallet for the PA. But these are at the booth, and Etienne and Justin are there. They're demonstrating that one of them is running, and then the rest of them are on display. So the 2 and the 600 have the clear top, so you can see the technology inside of it. Let's drop that down. Thanks, Etienne. That's awesome. Round of applause for that guy. He made it happen. He really, really, really made it happen. So, so that's the VX series. We've done the launch. We've got the booth ready. All the models are there. We were very, very proud to have been able to introduce this. The range goes from 150 up to 5 kilowatts, and I'm gonna dive into some of the details and blast along here. It's a ground-up design, so we just kind of looked at what we had done in the past. We looked at VS and other technologies that we'd invested in, and took the best of what we could. And we realized that with some of the other technological advances in chips and FETs and things like that, that we were able to take all of that and put together something that was a phenomenal analog FM rack mount transmitter. And that's what the focus is. As you could see from when Etienne held it up there, it's got a clean, accessible layout, very easy to maintain. You only need a Phillips screwdriver to do all the work. We've got things like solderless PAs. You can pop the filter cover off the front panel to wash the filter and then pop it back in again. 20-inch depth for your rack. It's mounted using the ears on the front there. There's no rails, and the power supply, you just literally pop it out and it comes out of the front. For a comparison, you can see that the VS 2.5 and the VX2 differ in weight by quite a substantial amount, and also the volume is also quite substantially different. We're not beating up on the VS because the VS is the flagship product that's continued to provide HD delivery. This is an analog series, so the VS series will continue to provide HD focus, and there's a slide that will illustrate that in a bit. Variable voltage power supplies, and they are titanium grade, which means they have an incredible efficiency. So I believe, and you can correct me if I'm wrong there, Etienne, that we can plug this into a 110 volt supply and for a 1 kilowatt model. So that's pretty handy. It supports the Orban inside feature, so you'll see the posts for it, and I think one of the models has an Orban inside it. We have a lot of design headroom, so the chipset that's in there has things that we can take advantage of in the future. And we've also got a solderless dedicated interlock, and as someone who has mucked about with that, yes, it's a pretty nice little addition. So yeah, it's pretty cool. It's worth it just for that, right? And then the front panel, as you'll probably may have just seen there, it's a large, large-ish. I mean, it's only 2 RU, but it's a large full color screen. And we use a rotating knob that you press to select, and then there's a back button. There's also dual state buttons on the front for things like RF and remote to turn those on and off. And the actual button changes color and the text changes. It's pretty cool. And then there's also a USB on the front, which allows you to do software updates, and you can put music in there and things like that. So there's still the USB at the back as well. So it's really just a convenience of, do you want it on the front or not? It of course, oops, I hit the wrong button there. It of course has the same AUI that all the other products are getting. This is the new AUI that everything gets. And we've talked about that already, and all the features that you know and love from the old AUI are here, like presets, notifications, scheduler, etc. So let's put it together and illustrate it by sort of comparing it to the VS series. First of all, you'd get improved affordability. The pricing is more aggressive, and we can essentially match the products that the models that we have already in the VS series. Obviously, there's the VS 2.5 relating somewhat to a 2, but we have those. But then we've also filled in. We've added the 150. We've got a 600. We've got a 1.5. So that's pretty exciting to have some extra ones there. It allows you to buy the power level you need, as opposed to sort of, oh, well, I'll get a 300 even though I only want 150. There's been, Etienne's team has used extensive new technology like thermal modeling and electromagnetic analysis to make sure that the design is just fine-tuned to the nth degree. It's phenomenal, and he'll be able to explain how those tools were used if you stop by the booth. And here's some of the specs that I don't specifically understand, but I'm expecting that you'll probably look at them and go, hey, that's pretty nice. Again, you can see those in the slides when you get them. The types of roles that it can do are typical, so main, backup. The 150 and the 300 are LPFM certified. Can be an exciter replacer, translator, SFN. And of course, with this kind of weight, it's a portable emergency transmitter. In fact, we're looking at equipping our salespeople with the Pelican case that this one is in. The combined weight of the Pelican case and the transmitter is just under 50 pounds. So it's actually checked luggage. It makes it really easy to go on the road and show off the technology all over the place. But that's not all we've got. So we've got also the up to 5 kilowatts. So this is something that is very exciting to have an addition here, which allows us to have 3, 3.5, 4, and 5 kilowatt models that are made up of two boxes. So there's the exciter on the top, and you can see that in this picture here, and that weighs about 15 pounds. And then without the power supplies, the lower one is about 50 pounds. So these are things that a solo person up at the site can install these into a rack with a degree of ease. And it has all the same sort of facilities and design intelligence that goes into the 2 kilowatt to 150. This one is still in development, but is in advanced development. So you'll see the prototype is on the floor, so you'll be able to look at this one as well. Here's the back of it, and this gives you an idea of the connector on the back and the kinds of connections that are there. So the full range, the VX series, is 10 models new, all analog focused, and incredible specifications, which allows you all the way up from 150 to 5 kilowatts to pick the TPO you really need. So in summary, here's a bunch of our marketing speak on this side, but on the other side, we've got the availability is that the VX2 will be available. It is available for pre-order now. And shipments will begin in Q4 of this year. That's calendar Q4. And the VX3 to 5 will be shipments will be in the first quarter of next year, 2023. So that's that. And then to give you a sense of fit with the families that we have, the whole Nautel suite of FM families, this illustrates. So if you look acrosswise, you've got the digital focus in the upper range, a swim lane if you like, and then the analog focus along the bottom. And so the digital focus, the VS series, still services that HD need. And then we've got MV Lite and GV that also support HD and of course analog. And then down at the bottom there, we've got our VX series, which takes you up to 5 kilowatts as focused on analog. So the next steps for you guys is, come visit the booth, see the AUI demo, if I refer back to that, and also see the VX series with hands-on. And if you're interested in the beta testing, just get a hold of me. And that, as I say, is that. Thank you, Jeff. And thank you.
I just want to give a shout out to the TELUS Alliance Container University. Even if you're not one of their customers at this point, it's a really useful source for educating yourself on containerization and virtualization in general. There's some really good points in there. All right, on that note, we're going to step forward. There has been a lot of talk about virtualization and some of the stuff we're doing. He's presenting a paper here, and I know he's going to refer to it, but I'm going to welcome Mr. Philip Schmidt.
Good morning. This is certainly a tough presentation to follow, a tough announcement to follow. But I'm going to use the good old cliche. Let's start thinking outside the box after having a look at all those nice boxes. Now we're going to look outside the box. So we've been on this journey for about 3 years now and trying to see how we can connect the transmitter directly to the cloud for all its content. And we've made significant progress about that. It tells me I'm muted on here. Okay. This way. There we go. So just the overview here is we're going to look a little bit through the system components of the system we've pulled together. And the key thing about it all is an integrated transport stream. And we'll get into a little bit of detail with that. The neat thing that we can pull together with that is we can now duplicate, we can clone multiple air chains because they're all in software. They're in containers, virtual images. Now we can clone multiple air chains and we can change over between them. We can have just standbys, we can have hot, cold standbys. We'll get into that in a little bit more. And we think there's significant IT security considerations that we can bring to the table here. Our focus initially will be to bring that to our GV transmitter series, but certainly there's a roadmap of moving forward with that. So let's get started. So we've already seen this demonstration picture here earlier in this series here. So we'll take you through all the different components in this diagram here, one at a time. So starting, we have a new announcement that we have essentially an Omnia for Nautel product, which is based on the successful Omnia 9 series. So you see a screen here, and it's totally feature packed. I don't even pretend to be able to speak to all the features that are in that audio processor. Certainly speak to our partners at TELUS about all the details within that. But the key thing about it is it does dual FM HD processing. So it processes the FM and the HD based on one common input and breaks it out to that point. So that's a key concept for the entire architecture. But not only that, it can do HD 2, 3, 4 all in one shot. So that's a really, really cool thing. So when we started talking, I think it was in 2019 when I talked to the designer of this product, and the things came together. That's really where things started clicking, and this was just a perfect fit for the concept that we were looking for. The other part of it is, you're familiar with the Gen 4 software, but we've changed it a little bit. But it's the same old. The core of it is the exact same Xperi software that's already running on our HD multicast today. We've changed the underlying audio driver infrastructure with it, so now it directly interfaces with that audio processor, and it doesn't go through audio cards. It directly talks to the processor without going through any kind of audio subsystem. There's no, Windows sound system. There's no Linux sound system. It's a direct sample connect between the two software pieces. And that's what Nautel is bringing to the table, the interconnection of those two. And certainly all that takes care of all your HD needs from interfacing to artist experience or station logo and your automation systems for all your HD 1, 2, 3, 4 audio streams. And there's a snapshot of some of the artist experience you can put on that as well. So to put all this stuff together, I thought this slide here is kind of interesting. So we've got this air chain, so that's the top left part of it. So how do we make that all interconnect to a transmitter? So that's kind of the crux of the architecture, the key of what we're bringing to the table here. So shown on the top left, 4 automation systems playing into an audio processing engine, and that could be over LiveWire, it could be over even Showcast, Icecast, or other AOIP standards. And as just talked about, the HD 1 to 4 is transferred directly from the audio processor in the HD radio encoder. And if you look at all the things that this transport stream carries, it's quite a bit. It's HD 1 through 4, program service data for all of these channels, album art, station logo, traffic. I didn't even put that in there, but any kind of traffic service or other data services. And you've heard Xperi talk about the new data services or the new service modes. So it will open up a whole lot of other application areas too. So all of the HD services are in it. But even composite MPX, you're probably familiar with that for the FM. It's very comparable to this E2X stream, the exporter to exchange stream. It's the analog, or it's a parallel to the analog stream, and it contains, of course, your left plus right, your pilot, left minus right, RDS, and potentially an SCA. I've put that in bracket right now. We don't have the SCA implemented today, but we can show all of these other components there today. And what we've ended up doing is, or what we're proposing, and we're proposing for standardization between the NRC and perhaps other bodies as well, is if we want to come up with a transport stream that combines the analog and the digital together. And if you put them all in one stream, they can't slip anymore. It doesn't matter how long it takes to get from point A to point B. If you don't let these packets pass one another, your diversity delay will stay the same. And that's what we're trying to demonstrate here. So the FMHD is locked on the right-hand side, no matter where you originate your air chain from. And that's really the key concept we're bringing to the table. The other portion that's with that is, not only do we want to put the E2X and the MPX together, but we need to govern how long it takes from ingest to broadcast. And we do that using a Nautel buffer control algorithm that we've come up with. And you can see that in our demo. We've got a little buffer plot. You can see the fill level of the buffer over time. So we've got a feedback loop that controls the input to the audio processor all the way back at the ingest of the air chain. And we essentially tell it speed up a little bit, slow down a little bit, so that the buffer stays at a target level. And it's a very slow loop, just so gradually move it up or down. So you kind of see when you start the system up on the left, you'll see a little bit of a wobble. That's the control loop honing in. And then thereafter, it's just reacting to sort of little network upsets and whatnot. So this plot here really shows you whether you have a healthy link or whether you have to actually address your network a little bit. For example, here you see a brief little drop in the middle there, but it wasn't deep enough to cause any outage. But it gives you something to look at before it becomes a problem. And by the way, this was captured using a Max Connect, and I believe it was on the AT&T wireless network at the time. And we're running this whole data stream across essentially a 5G to your transmitter. The new thing that we're adding here is now that we have all these air chains lined up, we line them up in such a way prior to the modulator that we can switch in and out both the FM content and the HD content prior to the modulator. And the reason why we want to do that, it allows us to gracefully change over an HD radio receiver from one air chain to the next. And we'll have a demonstration of that in a minute. And it is quite graceless and it's quite seamless. So this air chain selector allows you to choose which one of those is currently the active one. So we've got a little control GUI here that we could show on our demo on the floor as well, where you can configure a number of air chains, and you can assign them either to be a hot standby, which means it's connecting all the time to your air chain. Whether it's on air or not, it will try to connect. If it's the topmost one, it will make itself active. If it's one of the lower ones, it will make itself active if there's no other one. A cold standby is different. It will not connect to your air chain. It will save you bandwidth. But if there's no more hot standbys, if there's no more active connection, it will establish a connection and start producing that content. So the difference is a hot standby, we can do a very quick changeover. With a cold standby, there could be a little bit of an outage, but it's not an RF drop. We keep the RF carrier on at all times. It would just be maybe a few seconds of silence until the new connection is up and running, depending on how long it takes to establish a connection. So here you see Alex Hartman. He is currently on the show floor chasing Murphy away. And he's doing a fantastic job with that. But just last week, we've put the system on air at KVSC in St. Cloud, Minnesota. We've performed a changeover we had 2 air chains set up, and perhaps the next picture shows that a little bit better. We had one set up in the cloud, hosted on Amazon Web Services, AWS. And then we had another one on the bottom here. It's currently inactive in this shot here. Oh, why is it? Oh, yes, right. So the bottom one would have been running on an HD multicast. The top one is running in Amazon Web Services, and they're the exact same code. There's a saying that the cloud is just someone else's computer. So really, that's coming true here. So we've made a little recording, and probably it's a fairly busy recording, so I need to explain that a little bit. So on the right-hand side, on the top, you see Alex Hartman's Hyundai HD radio receiver in the car. And I wish the Nixie tube design would pop out a little bit more in this video. It's pretty cool, but anyways, you see all the pertinent information in there. So in this demonstration, we will switch over we'll start running on the cloud. We will then switch over to the HD multicast that's sitting right beside the transmitter. And then we switch back over to the cloud just to demonstrate what the transition is. In the middle, you see this air chain selector control screen that we've added. And you can pay attention to which one is active and inactive. I've got some visual cues in there to guide you. As a matter of fact, my 11-year-old daughter taught me how to add little effects onto this video to highlight things. So, learning from the pros. And on the bottom, you see Adjust an 808 by Innovonics that measures the FMHD delay. And you'll see no matter whether we're coming from the data center, which in this case would have been the Ohio data center in AWS, or right beside the transmitter, the diversity delay doesn't change. Because like I mentioned before, once we packetize the MPX and the A2X together like that, there's no chancing slip apart. So provided the rest of the system, our modulator keeps everything synchronized, then we've solved the diversity delay problem. So let's just run that that video, and hopefully it will come through. There's a little text description. Pay attention to that. It's a fairly busy one, but certainly we can make that available for you to view later as well. Do we have audio? We do not have audio. Yes, exactly. As a matter of fact, it's hard to correlate silence with silence. It says I am muted here. Is that why? We tried it earlier, worked. Go figure. There's Murphy. Right, exactly. Well, I guess we'll have to make that available offline. If we can get the audio sorted out now, that's too bad. But if you listen to it later on, pay attention to when it switches between the HD on cloud, it will switch over to the analog on the HD multicast. And the key thing here, now that I have to explain it in words, an HD radio receiver, well, we do the switch at the same time. We switch the HD and the analog at exactly the same time. But an HD radio receiver has 4.5 seconds of buffering built in. So we'll keep on playing the HD, even though it's no longer on air or not that stream is on air. We'll play for another 4.5 seconds. At that point, you're into the new analog. And the one thing that we wanted to highlight is it creates a nice crossfade. The blending function in an HD radio receiver, it will ramp down the digital and it brings up the analog when it falls back to analog. So we actually created a crossfade from one air chain to the analog of the other. And then once it's acquired the FM, it will then seamlessly blend back to the digital portion of it. And because it's perfectly aligned, there's hardly any impact. So that's what we wanted to show here, and hopefully we can demonstrate that on the booth. If you want to, see the demo in action, maybe that's a better way to look at it. Hopefully we can show all these ins and outs there. One thing when you watch the demo that I just wanted to highlight there as well, the way we had things set up, we were sending the main audio from the transfer site back out to AWS. So that introduced an extra second of buffering delay. So when we switch from, you'll hear that when we switch from the HD multicast back to the AWS cloud, you'll hear a repeat. That's not because of any misalignment in the HD or not. That's just simply the main content took an extra second to move back to AWS. We could take more care and align those a little bit better so it becomes even more seamless. But it also demonstrates the point you could have completely different content on the air chains and actually switch them over. So moving on, let's see. What's our next slide? A couple words about IT security. Now, people are scared about, is the cloud going to be reliable enough? Are we opening ourselves up to attack and whatnot? And yeah, IT security is definitely something you have to take very, very seriously. And one note before we get into it, embedded devices are no more secure than open devices. As a matter of fact, because a lot of embedded devices, you will not get a complete software bill of material. You don't really know what's in a lot of the embedded devices. They can actually be a greater security risk than some of the open ones. So anyway, so one of the risks that exists, if we have a listening socket shown by this red parabolic or that half crescent moon, if there's a listening socket on the downstream of an air chain like that, and maybe you've done a port forward to a firewall and it's out there listening, anybody can do a denial of service attack. Somebody could just try to initiate many TCP/IP connections, and even if they're not successful authenticating or whatever, it's still taking resources. It can take you off the air. So we said that's not a good idea. So we changed things around. And you'll see in a second why we do that. So we make the TCP/IP client server model more IT standard, where really the server out there is listening, not the client. So we changed that around. Now, does this mean you could still be attacked? Of course you can. But in this case, you're only impacting one of the air chains. So now you can switch over to another air chain. Your transmitter is still fine. You're behind a firewall. We're not opening up any port forwards. You're still protected there. You're just using standard ways of getting out onto the internet. And we can have authentication there to the server as well. So if one of these air chains becomes, well, we had disaster recovery earlier. It could be a fire. It may not be a hacker attacking you, but it could be a hacker. No matter what the disaster is, you fix it. And since it's all software, go from backup and you restore it. So a couple of words about, so how are we going to make this happen? So we have a new controller for the GV series that we've upgraded in terms of computing power. So on the show floor, we have one of these new ones in there. And as a matter of fact, the transfer that we're showing on the show floor, it's been with us since the GV introduction, I believe. I think it's the first model that was ever built. So we have a new controller that gets updated, and we have a card that goes into the exciter that takes a slot of the XGen card that interconnects the two, and it produces the on-air signal. And we're hoping to change, currently we have an analog and a digital GV version. Well, the hardware, the intent would be to be the same, and then essentially just turn HD on if you want to go HD. So roadmap today, I mean, the very first thing I want to mention, we're taking a couple baby steps into this right direction. So what we're introducing, we have a new software release for the HD multicast, and there we have the Omnia for Nautel already built in, but it's only for HD 234. You're going to have to wait a little bit for the FM HD1, the concept I'm talking about. That will be the next thing. And we're hoping to look for candidates that that are willing to alpha test this with us. We need to get some feedback as to, how this can practically be implemented. One of the areas that we really want to pay attention to is how would we integrate emergency alerting with EAS into the system? Could we have a separate air chain just dedicated to EAS, and how would that work? How can we integrate with various playout systems? So that's that. Those are the sort of things that we want to explore with an alpha test before we go into a beta test that has it all integrated into GV. We're going to add secure authentication. We figured initially, let's stick to a well-controlled network, maybe a VPN, whatnot, but we're going to add private public key authentication to the data stream so that when the transfer reaches out to the air chain, it can be assured that that is the air chain that you want to have on air. Initially, HD Power Boost is disabled in this mode. So there will be a bit of a hit in terms of transmitter power output capability. We're going to add that back in. So overall, in summary, we fixed the FMHD1 alignment problem, and we can demonstrate that. And it doesn't matter where the air chain originates. We're introducing a new air chain transmitter protocol that we're hoping to open up for standardization. We're hoping the industry will follow us on this. So we'll come up with interoperability with various components. And we have multiple air chains that help fight you to keep on air. We've demonstrated at KVSC. The one big thing that we want to highlight here is it's really solving many different problems. It's an HD solution, but it's also an audio processing solution. It's an STL solution. It's a timing solution. So by the time, if you do your system design, by the time you add that all in, it's actually replacing an awful lot of boxes. You'll always need a transmitter. You need your AC to RF converter. There's no way around that. But if we're going to limit the number of boxes that you will need. So that's pretty much it for now. If there's any questions, I can certainly take them after the presentations here.